Let's calculate osmolarity in 4 easy steps. Osmolarity is a measure of concentration. There are many different ways to express concentration, but they are all different forms of mass divided by quantity. When concentration is expressed as osmolarity, the mass is the number of osmoles and quantity is the volume in liters. Let's break this down. An osmol is the osmotic pressure produced by each mole of a substance in solution. Each mole is contributing to osmotic pressure. The pressure determines how water will or will not cross membranes. Hence the name osmol, osmotic pressure per mole. If you are unsure about the concept of the mole or equivalent weight, head over to pharmacology.com for the full unit on calculating milliequivalents. The amount of osmotic pressure exerted by a solute is dependent on how it interacts once it's in solution. The interaction is either ionic or non-ionic, and you need to know which to calculate osmolarity. Ionic solutes will dissolve in solution to form ions, and ions maintain some degree of attraction to each other in solution. Non-ionic solutes will dissolve in solution, maintaining the covalent bonds that hold them together. There is minimal interaction between solute particles. The degree of interaction between solutes in solution is represented by the osmotic coefficient, which ranges from 0 to 1. An osmotic coefficient of 1 represents an ideal solution where there is no interaction between the molecules. They exist independently of each other. You can think of an osmotic coefficient of 1 meaning that the particles are providing their maximum osmotic pressure. Any deviation from 1 means that there are other factors like electrical charges and attraction that is affecting the ideal osmotic pressure. Let's put this all together and calculate osmolarity in 4 easy steps, starting with non-ionic solution. First, we calculate the number of moles, which is always the given amount divided by the molecular weight. Then we convert moles to osmoles by multiplying by the osmotic coefficient. Since non-ionic solutes have an assumed osmotic coefficient of 1, for non-ionic solutions, the number of moles equals the number of osmoles. We then express the number of osmoles by a volume of 1 liter to get osmolarity of a non-ionic solution. For ionic solutions, we start out the very same way by calculating the number of moles. The only difference is that conversion to osmoles requires multiplying by an osmotic coefficient, which is some value less than 1. We express the number of osmoles by liter to get the osmolarity. Head over to pharmacology.com for sample calculations and a step-by-step guide to calculating osmolarity.